Welcome to Water Science for Everyone.
Imagine a world without a stable temperature, where some regions were scorching hot and others freezing cold. Our planet experiences vast amounts of solar energy, yet somehow maintains a relatively balanced climate. Have you ever wondered how Earth achieves this incredible feat? The vast expanse of our oceans plays a monumental role in this global temperature regulation. They absorb over 90% of the excess heat generated by human activities and redistribute it across the globe through a complex system of currents. This incredible capacity for heat absorption is primarily due to water's remarkably high specific heat capacity, meaning it can absorb a large amount of energy before its temperature significantly increases. Solar radiation penetrates the ocean's surface layers, especially in tropical and subtropical regions, warming the water. Once absorbed, this heat is not static. Ocean currents, driven by a combination of factors like wind, temperature, and salinity differences, act like giant conveyor belts. Surface currents, such as the Gulf Stream, move warm water from the equator towards the poles, while deeper, slower currents, part of the thermohaline circulation, transport heat over much longer timescales. The Coriolis effect, caused by Earth's rotation, deflects these currents, creating large circular patterns called gyres that further facilitate this global heat exchange. Understanding these processes is crucial for predicting global weather patterns and long-term climate changes. Scientists use an array of tools, including satellite observations, ocean buoys, and autonomous underwater vehicles, to track ocean temperatures and current movements. This data feeds into sophisticated climate models, allowing us to simulate how changes in oceanic heat content and circulation might influence atmospheric conditions, rainfall distribution, and even the frequency of extreme weather events. By monitoring these oceanic thermal dynamics, we gain vital insights into the Earth's energy budget and its future climate trajectory. A fascinating aspect of this system is the Great Ocean Conveyor Belt, a global network of deep and shallow currents that can take 1,000 years to complete one cycle, profoundly influencing regional climates. For instance, the North Atlantic Current, an extension of the Gulf Stream, delivers significant warmth to Western Europe, making its climate much milder than other regions at similar latitudes. Phenomena like El Niño and La Niña, driven by changes in Pacific Ocean temperatures, demonstrate how interconnected these systems are, causing ripple effects on weather across continents. The oceans store thousands of times more heat than the entire atmosphere, acting as the ultimate climate buffer. Ultimately, the oceans are not merely vast bodies of water but dynamic thermal engines, absorbing the sun's energy and meticulously distributing it across the planet. This continuous process is fundamental to maintaining the habitable climate we depend on. Recognizing the ocean's role in global heat transport allows us to appreciate its immense influence on our environment, underscoring the critical need to protect this vital planetary regulator for future generations.
If you love learning about water, like, subscribe, and keep exploring with us.